The Scientific Revolution by Jonathan Baker. Da 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 da. During the Middle Ages, most scholars believed that the Earth was an immovable object located at the center of the universe. According to that belief, the Moon, the Sun, and all the planets moved perfectly in a circular path around the Earth. Common sense seemed to support this view. After all, the Sun appeared to be moving around the Earth. It rose in the morning and set in the evening. The centered view of the universe was called geocentric theory. Beginning in the mid-1500s, a few scholars published works that challenged the ideas of the ancient thinkers and the Church. As these scholars replaced old assumptions with new theories, they launched a change in European thought that historians call the Scientific Revolution. The Scientific Revolution was a new way of thinking about the natural world. That way was based upon careful observation and a willingness to question accepted beliefs. Although backed by authority and common sense, the geocentric theory did not accurately explain the movements of the sun, moon, and planets. This problem troubled a Polish cleric and astronomer named Nicholas Copernicus. In the early 1500s, Copernicus became interested in an old Greek idea that the sun stood at the center of the universe. After studying planetary movements for more than 25 years, Copernicus reasoned that indeed the stars and Earth and other planets revolved around the sun. Copernicus's idea was known as heliocentric theory. About 100 years later, an Italian scientist named Galileo Galilei built on the new theories about astronomy. As a young man, Galileo learned that a Dutch lens maker had built an instrument that could enlarge far-off objects. Galileo built his own telescope and used it to study the heavens in 1609. Then in 1610, he published a small book called Starry Messenger, which described his astonishing observations. Galileo announced that Jupiter had 4 moons and the sun had dark spots. He also noted that the Earth's moon had a rough, uneven surface. This shattered Aristotle's theory that the moon and stars were made of pure, perfect substance. Galileo's observations, as well as his laws of motion, also clearly supported the theories of Copernicus. The revolution in scientific thinking that Copernicus and Galileo began eventually developed into a new approach to science called the scientific method. The scientific method is a logical procedure for gathering and testing ideas. It begins with a problem or question arising from an observation. Scientists next form a hypothesis or unproved assumption. The hypothesis is then tested in an experiment or on a basis of data. In the final step, scientists analyze and interpret their data to reach a new conclusion. That conclusion either confirms or disproves the hypothesis. By the mid-1600s, the accomplishments of Copernicus and Galileo had shattered the old views of astronomy and physics. Later, the great English scientist Isaac Newton helped to bring together their breakthroughs under a single theory of motion. Newton's greatest discovery was that the same force ruled motion of the planets and all matter on Earth and in space. The key idea that linked motion in the heavens with motion on Earth was the law of universal gravitation. According to this law, every object in the universe attracts every other object. The degree of attraction depends on the mass of the objects and the distance between them. In 1687, Newton published his ideas in a work called The Mathematical Principles of Natural Philosophy. It was one of the most important scientific books ever written.